Bismillahirrahmanirrahim. Okay, so we will now today complete the second part of the management science process. Let's just have a revision because this week we will have a quiz, okay, on this chapter. So let's have a quick revision. First, let me know the 5 steps in the management science process that we learned in the last class. I'm sure you remember them, all of those 5. They are very important, okay. That's something very important for the entire course, because we must know how to go about the problems when we get in the case studies. You must have seen that different companies have different types of problems, and they, after they define the problem, they can apply the tools. Although in those case studies also we didn't learn how to apply, but we know more what exactly is the problem, and that is the most important step. Okay, so let's revise Tazkir, all 5 steps in the management science process. Number 1 was the, who will tell? Yeah, good. Number 1, Fatima has answered first. So we have started with a good morning with Fatima. She says observation. That's number 1. And all the students are clear that observation means to see with objective. Number 2, after observation comes the next step, that is Lamia, good, problem definition. And the problem definition, and what do we mean by problem definition? It's not like writing the problem. It means writing the problem in terms of factors, variables, because we are talking about management science. It's a mathematical process. So we want to convert the problem into mathematical components, variables, constants, parameters, etc. So that's our second step. After the, okay, very good. What is your name? Ruba, and the first one, I don't know what your name is. Model construction. I have told you earlier that in your official WhatsApp numbers, you should use your first names or full name, whatever. Don't use short forms. It's unofficial, because we are in classroom. So let's have first name or full name in your profile so that the teacher can identify you. Okay, so anyway, no problem, that's good. Model construction. In the model construction, we arrange the factors, the mathematical components, mathematical components which we defined in the problem, and that was what we discussed in the last class. After the model construction, Angam and Belasan and Tala, Arwa, Najwa, good, Zai, these are the this is the step of solution. But before solution, is there any, between model construction and solution, is there any mid step, intermediate step, where we decide which tool to apply? What is that step between model construction and the solution? Do you remember? It's not written. I told you to just note down. It's written in the picture form in the last class, because I am just trying to make you revise so that you can write the quiz well. You remember this? Between the model construction and the solution, there was one more step in the picture form. That step is analysis, right? Analysis. So in the analysis phase, we Then after the model has been constructed, we look at the model and we try to see which tool will be applicable here, and then with the help of that tool we find the solution. After the solution comes the last step, as first Belasan, then Tala, Arva, Razan. Okay. So this is the implementation state. That means the manager or the decision maker will decide whether to apply the results or not, but the result has been received, and the main feature of a mathematical result is that it will not change, it will remain the same, and it's up to the manager now to accept that result or still go by his or her own judgment or use some qualitative method. So this is something we have discussed already. Now from the last lecture, there is an example of model, very easy, a very simple example, but we must learn. Okay, so to see how model looks like and why should we make a model, what is the reason. So this model is to be created from the problem which we have received, and this way we will pass through the steps of the management science process. So we got a problem, two problems are there. First I will read the problem and then we will see if what you understood. So this is something we didn't do in the last class, we will do it today. Okay, let me use okay. So there is a company, consider a business firm that sells a product, any product. The product costs Saudi Riyals 5 to produce and sells for Saudi Riyals 20. What is the model that computes the total profit that will accrue from the items so created or produced? So what we see here, it's a very simple question, very simple, but we are not looking at the simplicity of the problem. If many students will already have the answer. If you look at the problem, you will immediately say it's 15 Riyals, isn't it? The profit is 15, right? Or you don't agree with me? Is it 15 or anything else? Right, Fatima agrees immediately. She is good in maths. Okay, so there is no doubt, it's a very simple problem, that there is a company who sells a product for 20 and the production cost is 5. Rahaf also agrees. But the question is, we are not looking at the simplicity of the problem, but we want to understand the process, and that too we want to use the management science process to solve it. So in the management science process, we who will tell what was the formula that we learned in the last class? We learned that Z max or min, what was the next part? Subject to constraints, isn't it? Subject to constraints. This is what we have to reach. We have to reach here with the help of this. So what we do, first of all, observation of the problem. We looked at the problem. After looking at the problem, we are defining the problem. Defining the problem means we are trying to pick out the mathematical, like 5, 20, and we should also know what these are. It's written here, the production cost, we may say CP, cost price, and SP is 20. Is there anything missing? Yes, there is something missing here. Who will tell? What have we? Just writing CP, cost price, is equal to 5, and yeah, Asil, wait please. Let's have a discussion on this. You are right, 15, but we are trying to see from the process, we are trying to define the problem. Now look at the problem. Here, I say I have taken out CP is equal to 5 and SP is equal to 20 reals. Is there anything missing here? Something very basic is missing. Just observe the problem and see if I have written this correctly. Is there anything missing in my observation, in my defining the problem, that CP is 5 and SP is 20. So, can we add something? Very good, Razan, mashallah, good. So, you are right, CP, we have to mention that CP of 1 unit, okay, is equal to 5 and SP of 1 unit is equal to 20. That is very important. So, this is good, excellent. That is what we have to understand. So, we have got what we have got? We have got the suppose we say CP, number of items is X, SP, number of items is X, number will remain the same, isn't it? Number of production remains the same. So, what we can do, we can find the CP and SP. So, it is easy now, CP multiplied by X and SP multiplied by X. If it is, how many numbers it can take? 1, 2, 3, 4, 5, X can be anything. X can be anything greater than 0, anything, and it should be a whole number because the product will be in whole number. It will be 1, 2, 3, 4, 5, 6, 7, 8. Now, when we say X, this is CP, this is SP. When we multiply it, we get the CP of X. This is SP of X. Okay. We said last class, we said we will write Z. Here Z stands for profit, and we will discuss that in short while, whether we should write max min or not. Z is equal to SP minus CP. That is the very standard, very easy standard formula for finding the profit. Z is the objective we have to find. Z is equal to SP minus CP. SP is 20 multiplied by X minus 5 multiplied by X. All right. So, this became a formula for us, isn't it? This is now a formula. Why are we calling it a formula? We are calling it a formula because now it can be any student, any manager. It may be Arwa, Razan, Fatima, anyone. They become manager and they have to find the value of their profit. What will they do? Simply, they have to just know the value of X. They have to know the value of X. Once they know the value of X, they can easily put the value there, or even in the Excel they can simply write this formula, and they can just keep changing the value of X and they will get the right. So, this became a model, this is a model of profit for computing the profit. Now, let's return to the last class and see if you remember the components clearly. We had the formula Z max min subject to constraints. Now, in this formula, I write here again, Z is equal to 20 multiplied by x. Listen carefully, I am asking you a question. I am sure you will all be remembering an answer. Now here, what is the name of Z? Z is called objective, isn't it? Z is called objective in terms of the model that we learned in management science. Although here, we will just see how different it is. Okay, who will tell me what is the name of 20 and 5? What are these? First of all, tell me, are these constant values or changing values, 20 and 5? Can you change the cost price and sales price? No, very good. So, in the model, in the OR model, the things we cannot change, not just in OR model, in any mathematical equation, the things we cannot change are called, what is the name for that? Mathematical name? Constant, very good, constant. This will not change. Another name, another more technical name for constant in OR model, it is called, no, not independent. Very good, mashallah, very good, parameters. So, these values are given to us. It may be anything, sales price, number of products to produce, time that will be required for producing one thing, number of hours in one class. All of these are parameters, these are given to us, we cannot change. So, that is called constant parameters, as Rahaf Talat Belasan rightly said, this is fixed. Okay, then comes the x, number of products. What is this? This is very easy. This will change or not? X will change. It will keep changing. It is called variable. It is called variable. It will keep changing. So, this became our model. I mean, I am just explaining you this very simple example. It is there in the book, So, I felt this is very important to explain in process form, although every student in the class will solve this problem, that the profit is 15. I am sure not even a single student will fail to solve this, they will all solve. But the main idea is to understand this model which we have to create, model that we have to create, and that is Z is equal to 20x minus 5x. This is the model. Why we are calling it model? Because now just give me any values of x, I will just put here and I will get the value, even and that is manually. If I put it in Excel, again I do not have to do anything, just feed the value of x, I get the value of profit. So, this is a model. Model is a formula, model is an equation that we derive from the problem, and that is all management science all about, that the first step in solving the problem. Here we know, we can know that minus is the mathematical tool to use, or we have to multiply, we have to subtract, and what we have to do, we have to just solve this in this way, we know the rules. But in the management science, the OR, if we are using linear programming, transportation, we have to learn the steps to solve that special OR problem, OR model. So, once we have reached here, we are able. So, what we are supposed to do in any OR problem, as you might have seen in the case studies also, that suppose a star blend, some of you must have got a star blend, some of you must have got the case of Hotel Marriott, then hospital. You must have seen that there is a problem, beds, number of beds, waiting time, ticket price, etc., etc. So, that becomes the main problem, Then we have to model that problem. Now here you see only one variable. That's very important to understand. How many variables are here? Only one. Only one we have to manage. That is the number of units to produce. But in the real life situation, have you studied in the case study? In the real life situation, the number of variables can go up to thousands, even more. Constraints can be also many 100 constraints are there for any problem. We have to manage all the constraints. So then it becomes the complicated. Then the role of computer becomes important, and that's the reason in the first video that you saw on the application, that the role of computer, the fast computing, has made it easier. Yes, Belasan is right. A lot of variables in real life, not one. This is a problem. This will exist. That's why we said decision making can be of three types. One, who will tell? One is qualitative, one is quantitative, and the other is mixed. So in this problem, we have to find the profit. It's a pure quantitative problem. It's very easy. You give me the number of X, I will give you the profit, and there is no doubt, no ambiguity whether a manager named Fatima solves it or Arwa solves it. We get the same profit, and the same model can be used by different managers. But in the qualitative, no model, nothing like that. It depends upon the person, her judgment, her experience. In the mixed, it comes back to the manager to decide. This quantitative model gives the result, suppose it's 1000. Now the manager decides. Okay, so let's come to the model part. So you understand this. Now, why doesn't, listen to my question, this is very important. If you understood the essence of OR, why can't or why shouldn't it makes any sense to tell maximize? Okay, first of all, when it is profit, it's profit. We have to find the profit. So we are all clear that here it should be what, max or min? The objective function will be z max or z min. What do you say? We should write here max or min? Max. So you all understand this. This is simple, but it has to be clear for all of you that when we want to increase, obviously profit, the manager will like to increase. So the person wants to increase. So here does this problem max, how much can we maximize? Is there any limit to maximizing the profit here in this problem? What do you say? No, there is no limit. Why? Why is there no limit? But just look at the problem. We have to look everything inside the problem, not outside. In the problem, what is it that makes you think that there is, very good, very good. There is no constraint, there is nothing written that we only have 100 reals to produce the products, or we have only 5 tons of steel to produce. Nothing of this sort is written. So here there is no limit, it's infinite. The production can go and on and on and on. There is no constraint at all. So Z max will be going up to infinite, infinity. So this is one problem. Okay. So here there is no role of OR. There is nothing OR will do, because there is no constraint. OR works only when there is a subject to constraint. But what we learned importantly here is the model. We learned that this equation helps in solving the problem when we have these information. We have the parameters and we have the variable, we have to just find the variable, and that's if we decide how many we should produce. Here how many is infinite, we would like to produce as much as possible because there is no constraint. Let us go to the next example. In the same type of a problem, here there is a problem of constraint. The constraint is that the same problem, SP is 20, CP is 5, SP number of products we want to produce is X, but is X infinite here? Okay. Now, it says to produce this product X, we need 100 pounds of steel. Is steel a raw material? Yes. Is it a resource? Yeah, this is a resource. So, steel available with the company is only 100 pounds. Be careful, okay, because the next class probably I will decide whether to start with linear programming or we do another chapter first to make it easy, because linear programming will take 2 classes. So, what is written here, that to produce one product 100 pounds of steel are required. Now, this 100 pounds of steel is available, not required, available, and for making one product, one unit, 4 pounds are required. For making one unit, 4 pounds are required, or we can reverse it, 4 pounds is equal to 1 unit. So, I mean this is very clear. How many pounds does the company have? 100. So, obviously, if we want to find how many products I can produce, I can simply divide 100 by 4, I will get 25. This is the maximum, this X is the maximum, right? This is the maximum, this is the constraint, this is the maximum quantity this company can produce. Why? Because they have only 100 pounds. So, what does it mean? That Z max is equal to, the maximum is 20 multiplied by 25 minus 5 multiplied by 25, or 500 minus 125 is equal to 375 Saudi riyals. This is the maximum profit this company can make, maximum. Is there anything less? Yeah, of course, it can be less. They decide not to produce 25, they decide to produce 24, 23, 10, 5. So, it's the decision of the manager. But the OR model has given the formula, using this formula, Z max is equal to 20x minus 5x subject to the constraint of steel. The constraint is equal to 100 pounds of steel, and for one unit 4 pounds are required. So, the max is 25. So, here what we see in these two problems is very important to see and remember that in the first problem there is no limit, no resource, no constraint. Okay. So, remember this, in this slide you can note down, there is no constraint in problem number 1, but there is a constraint of steel in problem number 2, and that is why we are using OR. We are using OR to know how max or how min can the cost or profit be within the constraints. So, we see how constraints affect. In the first case, there was no constraint, the profit could be infinite. In the second case, there is a constraint, so that limited the production. I mean, Now the manager, no matter how he does, how she does, it has to be 25 units only. It cannot be more than that. Okay. Now, can the company make infinite profit in one? Yes. Okay. Can the company make infinite profit in example 2? No. How much maximum they can make? How much is the maximum they can make? 3, how much? 375. Huh? Yeah, they can make max 375 reals profit. Okay, so we can calculate first two benefits of using the formula. One, we are able to calculate the profit. Second, we also know how many number of products to produce. That is also clear. We know that we want to increase the profit. So the max is 25. So we decide to produce 25. If we produce 25, we get the profit of 375. So it made life simple for the manager to make a decision and also give a projection to the company, to the finance department of the company, that this is the profit we are going to make and this is the maximum number of. So two departments get their figures. The operations department know how many they have to produce in the quantity, and the finance department knows that this is the profit we are going to make. Okay. Now, can you name the variables, parameters and constraints in example 1 and 2? We already did it, isn't it? Will you like to give the answer? Okay, good. So, the variables, good. Quantity, we called it X. Parameters 20 and 5, the cost price and the good, very good. So, cost price and the sales price is the parameter. There is another parameter given. Who will tell? There is a third parameter also. Yes, you are right. That's 100, and related to this is another parameter, that for you making 1 unit we need 4 pounds. That is also a parameter, we cannot change it. I mean, the class is of 50 minutes duration. Now the program manager or the chair cannot change it. It has to be 50 minutes. All the scheduling will have to be done based on that. The flight time is 2 hours. It has to take 2 hours. We cannot change it. So that's also a parameter. You got it? 100 pounds and 4 pounds. Okay, 4 pounds also. To make 1 unit, we need 4 pounds of steel. Right? Okay. Then constraints. In the first problem, is there a constraint? No. All of you understand this? Any student who didn't understand? You can ask me now here, so that you don't make any mistake in the quiz. So constraint is no. In the first example, there is no constraint, and in the second example, the constraint is this 100 pounds of steel. All right, let's move forward. Can we go forward? Okay. Now let's come to the main item to learn and enjoy in the management science, is to see the variety of tools that we have. Like in the so far, we were seeing simple mathematical problems. Now let me first ask you, you are seeing the picture, it's from your book. Now tell me which all names you already know, you studied in the case study or the video example. Who will tell? Have you heard about any of the names which are written here? Let me just tick the names that you already have, are familiar with, you saw in your case study or in the video, or I spoke in the class. So far this is the 4th class. Let's see, let me just tick. I will give the points, which is the most famous. Okay, so let's have a ranking of these tools. Tell me. Linear programming, okay, Razan, linear programming, number 1, they got 1 point. What else? Probability, where is probability? Yeah, 1. Okay, come on, all the students, You all did case studies, right? Tell me which all tools have you used already? I mean, you learned about them, heard their names. Simulation, where is simulation? Very good. Okay, so we got one for simulation also. Queuing, yeah, queuing, where is it? Queuing. Ah, yes, one. Probabilistic techniques, queuing. Network techniques, very good. So we write one here, network techniques. Sensitivity analysis. Where is sensitivity analysis? Sensitivity is in simulation. Yeah, yes, linear programming. Okay, game theory, very good. Game theory here. Okay. What else? Any other name? Other students? Why only few? You all did the case studies, so I mean, you can repeat, no problem. Okay. Any other? Did you heard anything about forecasting in any of the cases? Transportation, good. Transportation. Tala says, in which case study was transportation? Oh, in the video example, of course. Yeah, in the video example it was there. Okay, so transportation is here in the it's the computer solution, and in the linear programming also transportation is there. All right, stop. Very good that you. So we can see that by now, you know, we are familiar with some names of the tools and techniques in management science that will help us in solving the model, you know, that we create. So it's very important for us to have a theoretical knowledge first, to remember all of them, the names of them, and you can see, you know, there are two branches from the top, from management science techniques. Here there are two branches, one going this side and the other is here. This one is the, you know, the companion website. In the book has the book has given some tools. They are available with the companion website of the book, and we can use the tools which are computerized tools available. But the most important ones which we have to remember, the classification of the techniques. So let's look at them, and this is we are going to do it quickly because we have to complete this chapter. Okay, so yeah, maybe the first, these are the main tools, and the other one, you know, this side one, this is the computerized tools available with the book, you know, which they are prescribing in the book. If you'll see, if you get a chance to go through the book, you will see they prescribe that we are going to solve this problem using simplex method on the computerized the website. You know, they have given support materials for the solution of the problem using computer methods. But the main techniques theoretically are divided into four. Number one is linear programming, linear mathematical programming. Number two is called probabilistic techniques. Number three, network techniques, and number four they have classified as other techniques. Other techniques are those which fall outside these. So first of all, you know, the most popular, as you can see, linear programming is something which has been very common, which has been used in many areas, and it's the most common among all the techniques which is used in management science. But most common doesn't mean that the others are not used. They are also being used, and in some areas linear programming is not required. We need other techniques like transportation, or CPM PERT is used for project management. So they are required. But when we learn about management science in most of the textbooks, linear programming is the most common. But this classification given this textbook is very good, and it's useful for students to remember the tools and techniques in the four categories. So let's look at, first of all, look at the names, familiarize yourself with the name and in which category it is. So the first technique is called linear mathematical programming, and in this technique we have the tools named linear programming models, graphical analysis, sensitivity analysis, transportation. We are going to use graphical method to solve the linear programming model. We will learn how to do it, but this linear programming can simply be solved using the companion website, you see, simplex method, or in Excel also. If it is a very simple problem, even in Excel we can do it, but we will learn the graphical method to see what is meant by feasibility. That is our next target, agenda. And the next chapter, if we start linear programming, I'll think on it this week after seeing your quiz results, how you are doing. So then I'll decide whether to go for linear programming first or to start with a simpler chapter first. So that's the first. All of you, just read in your minds all the tools which are written, and remember these all belong to the technique category number 1, linear mathematical programming. What this is, we will learn in linear programming. I'll explain to you what does linear actually mean. Okay, so just for the sake of and this is linear in a graphical method. That is why I teach graphical, because I feel this is this explains very well, and it gives a very clear idea in terms of picture what graphical is. Very easy to identify. There are two graphs, one like this and there can be graph like this. Okay, let me just ask you a general question. You have already done marketing. Have you seen a graph like this anywhere? And slowly, who will tell? Let me, this is a general knowledge, okay, not bonus, but yes, I mean I will always remember PPT. What is PPT? Have you seen a graph like this ever in business? In which department or in which course have you seen this type of a graph? Very common graph. Who will tell? Oh, many students are economic. No, I mean I want something better than this. Production, no. Sales, okay, sales. Let's go from here. Sales, sorry, sales. So in sales, can you clarify further? Very good, mashallah. Product life cycle, excellent, mashallah, very good. So this is not a linear curve, right? Linear curve. We all agree, this is not a linear curve. So this is something very basic, you all know. So we don't need to explain now what it is, but we can simply see, and every student can tell that this is not a linear graph, and this is, and good, Tahani is right. This is in marketing, all of you right now, Shahid and Tahani, these are the stages of the product life cycle. This is not. So in the graphical method, we can easily say that this is a linear problem or this is non-linear. Okay. So in the linear mathematical programming, the tools are linear models, graphical analysis, sensitivity analysis, transportation, transshipment and assignment, integer linear programming, and goal programming. These are the different types of tools available for solving the linear mathematical programming. We are not going to learn obviously all. You will learn them as you grow and become a specialist. You will learn to apply, but we know that these are there, and we will see, and you must have seen some in the case studies. We will try to, and you have to try, because while we start taking up chapters on each, it will not be possible for me to find applications of each of them. It's up to you how better, how interesting you can make. Try to find Now you have the names. Try to find in which business problem sensitivity analysis was applied, how it was applied. In the book also it's there, but since we are not covering everything, I cannot give the example of each of them. So you are free to do that in the group. You can just give an example. One, in simple way, sensitivity analysis was applied in following this problem, okay? And this way what will happen is that when you go into the next higher studies, or you try to become an OR expert, you already have some idea where to apply, and then you can build on that, okay? So these are the names of the tools in category number 1, linear mathematical programming. Number 2, probabilistic techniques. Probabilistic, if I am not wrong, it's called ihtimal. If I am right, this probability is called ihtimal. Yani there is some sort of uncertainty. I mean, there can be yes or no, or more choices are there. There are, suppose, economic condition next year after lockdown is over. How will be the economic condition in the next year, in the next 5 years? Is it going to be good, very good, bad, worse? So there becomes 4 scenarios. So probabilistic techniques, as the name suggests, we'll just see the explanation also. In this technique, there are 3 main tools which are mentioned in the book. One is the use of probability and statistics that we apply in research methodology, also to find out, and then you apply where you apply probability and statistics in sampling control, quality control. Where is quality control? In which department? Quality control. Have you heard about quality control? Which department actually has this in operation? Too much? Operations management. Very good. Operations management, there is quality control. So what they do, have you already taken the course, technology and operations management? It's over? Good. So in operations management, you must have learned that the quality control uses probability, isn't it? Sampling control. What they do, it's not possible for Pepsi to, or Almarai Corporation, say it's our company, local company. So every day they produce and package so many bottles of milk, but it's not possible for them to test each and every, right? So what they do, they take up sample. Every day there is a quality control department who takes out the sample from the every lot and checks them, the purity, if there is any mistake or problem or not, and then they say okay. So the entire bundle, that is the use of probability and statistics. The second method, very useful and popular method, is decision analysis, where we use the tool to take a decision in uncertain situation. It's a very useful tool. The third probabilistic technique is queuing. Queuing is the it's also called wait line method, waiting line. So in waiting line, as soon as you hear this word waiting line, we simply get a picture. What? Cash counter, a cashier, and there is a long queue standing. So obviously it's dealing with that, okay. So the waiting line is a very common problem in service industry, mainly services, where like STC, Mobile, banks, hospitals, and we heard about waiting line in the St. John's Hospital in UK. She was telling how they want to minimize the queue. There this tool can be applied. This is a mathematical tool which can be applied to reduce the waiting time for the customers or the users. That's category number 2. 3 methods are mentioned there. Category number 3 is called network techniques. Network techniques, that's mainly dealing with network flow like in the production or the transportation also. And in project management, it's a very common tool to use critical path method, and there is another one called project evaluation and review technique. Two methods are very common in project management, which helps us manage the projects. Mashru. And where do we normally see projects? In engineering, isn't it? It's in engineering mainly. Big projects are there. So normally, those are the that area, engineering area. The project management is very common. In fact, many engineers, they specialize in project management, because there it's all about normally most of the tasks they do in form of project. Any other area where it's done as on project basis? Do you know any other industry? New industry. All engineering is old, building, construction, roads, but any new industry in which project management is very common, where the tasks are done as projects. Do you know? Flying department, yeah, that's again engineering, aeronautical engineering. They do, but an intangible item, ghair lamus. What do we say? Ghair lamus. In the intangibles, in the modern industry, there is an industry where it's very much they use the project management techniques to complete the production, to complete the operations. Let's see if anyone can relate with that industry. Digital marketing. Yeah, you are close. And I'll just stop the discussion there. It's IT. In the field of information technology, the development of softwares, fingerprint system, of all of these, these are all related to the IT. So what happens? Suppose as Fatima said, digital marketing. So a company is trying to develop a digital marketing software. Now this software becomes a project for the team. So you must have studied this in organizational behavior also, the different types of management. So there are some industries where it is team management. So what they do, they assign the task to a team. There is a leader. Very good. Yes. Management information systems. You are right. IT, management information system. So they as a team leader, and then the team leader will have the members. All of them together have a task to complete the project. So there also, they use the CPM or PERT method to complete the task. Now coming to the other techniques which are not classified in any of the three. So we can understand that the most important ones which fall purely under the management science technique are linear mathematical programming, probabilistic, network. Okay, and the fourth is other techniques. What are these other techniques? First, analytical hierarchy process, AHP. AHP is also used in research methodology. We will see in research methods there also we use AHP for qualitative analysis, content analysis, also qualitative analysis. Then the second is non-linear programming. Suppose something like this type of a graph, we cannot use linear programming. Here you will use non-linear programming. Simulation is a technique that doesn't fall in any of these three, but we have clearly seen that simulation is a very important tool to solve OR problems. Forecasting is mainly to project the future sales, production, etc. And inventory, makhzoon, inventory, how much raw material, or so it again depends upon the forecast. inventory depends upon the forecast, isn't it? The actual production and inventory. What types of inventory are there? I mean, we will not be able to cover inventory here because you already have done it in supply chain management and operations. So, I mean, I will have to skip this, but here let us just see if you know inventory. How many types of inventory are there? Who will tell? 3. Okay. What are those 3 inventory? Merchandise, good. Okay. Finished products, good. Finished products. Okay. Let us have other 2. Materials, okay. Raw materials. And the mid one is is there anything, something here also in mid? One is the raw material and spare parts, accessories all come here. Then there are finished products. What is the here? Is there something here also in mid? During the production stage, there are 3 stages. 1, raw materials. Then what is that called? It is an accounting term also. I will give you the short form, WIP. Who will expand this? WIP? Yes, work in process. So, this work in process, these are semi finished products. These are not ready yet, the products are not ready, only the parts are there, but they will, suppose Dell makes computer, there are several parts, they are all ready, now they have to be assembled. So, when they are in that stage, that is the work in process, that is also an inventory. Okay. Now, one single question and then I will stop the discussion on this, because I want you to revise this, and as I told you, please do not just limit to the discussion in the class, you are free to share the discussion that we do in the class, in the lecture on the day, to share information, more information later in the group. So, tell me, inventory, is it good for a company or bad? Who will? It is a debatable thing, just take 1 or 2 minutes to tell me. Inventory. Inventory is what? Raw materials, work in process, finished products, which are bad if it is high volume, and Tala says it is bad. It is bad. Huh? Why is it bad? What is the main reason from from business point of view? What is the main reason it is bad? If you use it efficiently, it will be good. Let us look at the reason. I mean, there are two categories of students now. One says, 2 say that it is bad, 1 say it is good. But let us look at the bad. Why is it bad? What is the main reason? Whether it is the raw materials or work in process or finished products. Why is it bad? What happens with that? For example, we say the classes are not going on, online classes are going on, but the classrooms are already there in the colleges. So, those are inventory, the chairs are inventory. The online classes are going on, the chairs are still there. Yes, you are right. The most important problem with inventory is the cost, and that is why I will just stop with this last hint on explanation, because I taught supply chain management also. Luckily, some years ago I was given supply chain management. These are all interesting areas, and you can teach from any direction, whether it is mathematical or non-mathematical. So, in supply chain management, inventory management is one of the most important areas. Now, cost. So, what happens with this cost? Inventory comes with a cost. Like we have chairs. You are right. Fatima is right. Tala is right. Cost, obsolescence. The products become obsolete, and then it is above the company capacity, it's overloaded, that's also bad. So, and only one student has supported that if it is efficiently used, it will be good. I agree, that's okay, that's fine. But looking at the cost side, what happens? The chairs are already there in the classroom. Now there will be nazafa, there will be someone to clean, someone to maintain. Still, the chairs will be getting damaged, or they will be getting inferior quality because of the time and not use. So, and the same with computers, the same with other items. So, this is the cost of holding in inventory. There are many costs. Now, it's a very famous saying that inventory is a necessary evil. I mean, even though there is a cost, even though in Japan there is a technique called just in time, where their target is zero inventory. Practically this is not possible. Practically this is not possible. So, when we look at the realistic thing, we know that we have to keep inventory of raw materials, of work in process, of finished products, all of them, because each of them, and now it will go into detail of supply chain management. We don't want to do that. We have to learn that it has to be there, and our target is to optimize the inventory. Why should we have inventory? What are the two things to manage? One is the cost, to minimize the cost. On the other, we cannot minimize the cost to a level that the customers return from our outlet. So, suppose Samsung has launched a product, and Samsung has launched a new model. Customers go in the shop and they don't get the product because it's out of stock. That's bad. Why? Because the customer will become dissatisfied. So, in inventory management, we have to manage both the cost and the customer satisfaction. I mean, this you must have studied in operations management and supply chain management. That is, and so for inventory, it's very important that we do it mathematically. Forecasting is very closely related to inventory. Apart from forecasting, we also must know how much we can produce, our production, the costs of inventory has to be clear. Holding, carrying, ordering, these are the costs related with inventory. Okay, so these are the 4 techniques, right? So all the students have memorized these 4. Okay, I will ask you later. Let's move forward very fast. We move each of these techniques. In linear programming, we don't waste much time here, because in the chapter I will explain in more detail. It's to identify the technique does not refer to computer programming, but programming doesn't mean computer programming, but it means algorithm. This programming here means steps, algorithm. It doesn't mean computer program like coding. It's the algorithm that we use to solve the problem. So we have to learn those steps. Probabilistic techniques means that it assumes that the problems are not certain. In probabilistic, am I right? In probabilistic, we in general techniques, other techniques, like if we say z is equal to 20x minus 5x, what is it? Is it sure short, or there is some uncertainty in this equation, in this information? What do you say? It's very clear, sure, or I mean it's sure or not sure, unsure information, uncertain. What do you say? Is it, Razan? What do you? Fatima says certain. Yes, this information is certain. There is no if and but. I mean, tomorrow I will say there may be a quiz on Thursday. Maybe, Rubama. Perhaps there may be a quiz on Thursday if there is no rain. So what happens here? Now the problem becomes uncertain. So those problems, understand this carefully, okay? Those problems where the information is certain, it's perfect, that in those places we use deterministic techniques. Those problems are called deterministic. But in problems where the input is not certain, the input or the information is not certain, it depends upon some situation, it's called uncertain. Those problems or those techniques are called probabilistic techniques. In probabilistic techniques, there will be some conditions that will change. So it may be economic condition, there may be business prospects, etc., etc. So we have to understand today, we have to just understand, remember the definition, that the probabilistic techniques refer to the problems where the information is uncertain, contain uncertainty, and so there is a possibility that alternative solutions might exist. So here we got the idea that if I tell you the number of items, it's 5. So it is 100 minus 25, 75 is the profit. But in probabilistic technique, it is possible that with the same 5 number, we can get 2 different solutions. Don't ask me why, I am just giving you a hypothetical problem, okay? It's just a hypothetical example. Don't ask me how is it possible. I am telling you this is how probabilistic works. In probabilistic, even though the input is the same model, z is equal to 20x minus 5x, the raw material or the product number is 5 only, but we get 2 values, one 75, the other is 50. 2 solutions are also possible. So that's what you have to understand, that in deterministic, the solution is 1, but in probabilistic there may be more than 1 solution. You will remember this. In probabilistic, more than 1 solution is possible. More than 1 solutions are possible, but in deterministic, 1 solution. So which is easy for manager, deterministic or probabilistic? Which is a easy tool to handle? Tell me, which is more easy, deterministic or probabilistic? Yes, of course, deterministic is easier, but as we saw, there are many problems where deterministic tools are not possible, because suppose after 5 years, you are saying you are predicting your sales, isn't it? You are predicting your sales after 5 years. You can use a deterministic technique and get a solution. The solution will be 1. You can say, okay, my sale will be 1 million. But how real it is? Because aren't there other factors which will affect your sales? Yes, there are. So when there are other factors which are beyond our control, like economic condition, like raw material availability, I mean, that NEOM, the line, have you heard about this name, line? All of you might have heard, line. Isn't it? It's a very famous word. You have all heard it, right? You are all business students and you are closely following. Maybe you will get a job as a manager in this project, the line. You will all live there. What is the thing here? What is the main idea in this project? Not just here, but in the entire world, they are all talking about alternative energy, alternative source of energy. So it means, sorry, what happened? It means that today the energy is mainly coming from oil, petrol. Means the entire world is dependent upon petrol, but petrol is non-renewable. It's finishing. It has a time. It has a life. They know that this petrol will no more be available. So what they are doing, they are looking for alternative source of energy. Now, if you tell that after 5 years, will I be able to receive the same raw material? It becomes uncertain. So here, deterministic technique will give a fixed value, but as a manager, how far can I rely on this decision? It becomes a question, isn't you understand? So that's why most of the times, many of the times in managerial problems, we will have to use probabilistic techniques. The ones we just saw, probabilistic techniques here, probability, decision analysis, queuing. Even in the nonlinear programming, it will be a probabilistic technique because the solution will keep changing. So let me quickly check. All those students who have just written, they will not answer. I am asking you a question, and maybe what I'll do, I'll stop here. I'll not go further, isn't it? It's too much. So we can take it to the next class, because I have to explain the computer solution also. Tell me one thing. There are more than one solutions in which type of technique? Deterministic or probabilistic? New student, I need an answer from a new student, not the ones who have already been answering. Give them a chance. Tell me. More than one solution. Very good, Lamia, but you are not new, you have been answering. Probabilistic technique, good. So probabilistic technique, we have more than one solutions. So it's difficult, but it is a pure mathematical technique, and like weather forecast. You have heard about hope? Have you read something about hope? Who has heard about hope? What is hope? Let me just clarify this, Tala, and then I will explain what deterministic and probabilistic is. Hope. What is hope? Because this was a project which has become successful. They started in July, and now it's successful. Anybody has any idea what is hope? No one. Okay. So the UAE, they sent a machine in the Mars. They have reached it on February 8th, I think. It has successfully entered the, and you can see the length. It's millions kilometers. The distance from Earth to Mars is in millions, and the project means the project means that there are so many items which are uncontrollable, because the satellite is going from Earth to Mars, traveling so many kilometers. So obviously here we cannot use deterministic technique. We have to use probabilistic technique, and probabilistic technique also works. There is a margin of error, as you have heard in research methods also, margin of error plus minus something. With that margin of error, something like which space shuttle there was a US space shuttle which just at the point of entry into the Earth's space, it was destroyed. It broke up. So that's also possible. There is a plus minus chance. You are right, Bilasan. It happened a few days earlier. These are all business problems. These have all business applications. So that's why it's important for us to keep reading and keep ourselves. Okay, now come back to Tala's problem, and with that we will stop. but you will have a quiz, don't worry. You will have a quiz this week with what we have covered till here, other techniques. The computer solutions I'll take it to another chapter, because this is a full chapter. So we have completed the modeling and the management science process. You will have the quiz till here. Okay, now let me just again explain. Let me say, this is deterministic and this is probabilistic. Now deterministic is are problems where the conditions are constant. Conditions are constant. But in probabilistic, conditions are not constant. I mean, there is no control over, suppose we say economic condition, foreign exchange rate. There are some examples we will see in nonlinear programming. Foreign exchange rate. So this is a very classic example of foreign exchange rate. Listen to it, listen carefully, okay. Suppose, I have the same problem, z is equal to 20x minus 5x. This 20, is fixed. It doesn't change, does it? No. But can it change? Yes. This money, this is the production cost and this sales cost. But we are selling to Japan. I get 5 reals, I get 5 yen per unit, 5 yen. Yen means what? When it comes to Saudi, it has to be converted into a real. Does it change? Yes. Isn't it? Real, yen will change. Foreign currency keeps changing value. So someday the yen value is 3 reals, sometimes it is 4, sometimes it is 2. So what will happen? Even though the model remains the same, the condition is uncertain. We cannot predict how much will be the value of real exactly. We cannot say, okay, I am exporting my products to Japan, so my production cost is 20. That is okay. I produce in Saudi, that's fixed, and my production cost is 5. It's fixed. But my sales price, will it be fixed? Will it be always 20 yen? No, I don't know. This 20 yen, when I convert into real on 13th February, it may be 160. On 14th, it may be something else. On 15th, something else. Why? Because the exchange rate keeps changing. So since this exchange rate keeps changing, this equation will also keep changing. You understood? So in deterministic, the conditions are constant. Result will be constant, one solution. In probabilistic, the conditions are not constant, they keep changing. So because they keep changing, the solutions are also maybe more than one. They can be more than one solutions. Now it depends upon the manager to decide which one to go for. Okay, then network techniques. Network techniques are represented as diagrams. Let me just remove this first. Network techniques are represented as diagrams. Like in the case of programming, CPM PERT, project management, we normally make a diagram to represent the problem. They have mathematical relationships, they have some formula to find how many days will be required to complete the project, what will be the cost to complete the project, etc. But it is also represented in the diagrammatic form. You will see something like this, etc. This way, it's like a decision tree analysis, but here projects are divided into small components, and then phase by phase projects are completed. The days are calculated. How many days will be required to complete item number 1, item number 2, etc. These models offer a pictorial representation of the system. And importantly, the project management or the network problems can be of both types. They may be probabilistic or they may be deterministic. So, if you are very sure that I am going to take 2 days to complete this task, then 4 days to complete this task, you are very sure, then you will use deterministic. But you are not sure, you say, okay, if the weather is good, I will take 2 days. If the weather is not good, I may take 4 days. Then in that case, the technique that will be used will be probabilistic. So, network techniques can be both probabilistic or deterministic. Okay, that's too much for a general introduction to the types of techniques. Then there are some other techniques like analytical hierarchy process. It's a mathematical technique where it helps in choosing between several decisions. Simulation is the making of the model in a computer, as we saw in the Tata Steel problem. So, what they do, they make a artificial system in the computer and they make the necessary changes and control to solve the problem on the computer, and then they can replicate the solution in the real life. That is simulation. Okay, we will stop here. We will start with from here in the next class. I will make a new chapter of this called computer solutions. That is very interesting. And then after that, we will. So, we will have a quiz till here to quiz on. Okay, now tell me, first of all, Tala, are you clear now the difference between deterministic and probabilistic? Okay, good. Now, let me ask you something. For the 1 hour activity like quiz or assignment that we are doing, is Thursday okay, or you find Saturday to be a better day, Friday, Saturday? It's up to you, you suggest, because I found, because you have classes till Thursday. So, is it, I will stop recording now because